Okay. Shall I start? Thomas?
Yes, you can.
Okay. Good afternoon, everyone. Do you hear me? Do you hear me? Yes, thank you. Yes, I'm happy. So good afternoon, everyone, and welcome to today's webinar. I'm happy to have all of you again with us to attend the fourth webinar about real-world application of machine learning and deep dive into ChatGPT and era skill demand. This webinar will be given by Dr. Jihad Zahir. So we appreciate your dedication, your engagement to the online chapter and the online webinar. And thank you for taking the time to participate. And we look forward to your continued engagement by reading the online chapter and attending the online webinar. So first, let me introduce our guest speaker for today, Dr. Jihad Zahir. She is an assistant professor within the Department of Computer Science at the Faculty of Science, Smelaliya, Qadi University, Marrakesh, Morocco. She holds a PhD degree in computer science, and her current research interests are mainly focused in artificial intelligence, natural language processing, and natural language understanding. She authored or co-authored a number of scientific publications in the topic. She also co-chaired and contributed in many international scientific conferences and workshops. She received one of Data2X Big Data for Gender Challenge grant. So we are honored to have here to share with us knowledge, insight, and her work. So before we start the presentation of our speaker, I would ask you to put your question in the chat. We will be moderating your question by the end of the presentation. So our speaker will give a talk of around 45 minutes with 15 or 20 minutes to answer the question that you will be posting in the chat. And so we are recording this webinar for those who want to rewatch the recording, or those who are unable to join us today. The recording will be put it in the Reddit platform, the platform that you can again post your question with regard to the chapter or the webinar. So the stage is yours, Jihad. We will be happy to listen to your presentation.
Thank you very much, Dr. Sana. Thank you all for being here, for participating in this webinar. So as Dr. Sana said, I'm Jihad Zahir, Associate Professor at Qadi Iyad University. I specialize in natural language processing, and today we'll be I'll be sharing some of our experience in machine learning, and I'll be sharing with you some real-world applications, examples of projects that we've conducted within our team with my partners and with my students, master's and PhD students. So sorry, this is not the beginning of my presentation. I'll do oops, and we'll be good to go in 2 seconds. Okay. So as I said, there are many applications for machine learning. It starts with social listening, and social listening is a way that we use to collect information and to generate knowledge using user-generated content. User-generated content is anything that users are producing when they use internet and the web generally. And this part of social listening is generally referred to as opinion mining or sentiment analysis or topic modeling. In all cases, these are the techniques or the set of techniques that we are using to extract information from data collected from Facebook, from Twitter, from other platforms, collected from from news websites, etc. And of course, to extract this information, we need to train machine learning models. Also, one of the applications of machine learning is conversational agents. You all know, of course, now the LLMs like ChatGPT, Gemini, Llama, etc. So these are examples of conversational agents, and we have also to develop this kind of conversational agents and chatbots, etc. So we use heavily and we rely heavily on machine learning algorithms. Machine learning is also being used in healthcare and other domain. For example, in healthcare, we use it for patient outcome prediction. If we put a patient under a certain treatment, we need to know how efficient will be this treatment. And we can use machine learning to predict the outcome of a patient given a certain number of factors. We can also use it in healthcare for recommendation. For example, you all know, or you are all familiarized with recommendation engines because you are being confronted to recommendations all day long when you are using different platforms. In healthcare, we can use recommendation to recommend, for example, a treatment path, or to recommend something specific to patients or doctors. One of the applications also that are being used, especially in finance and in law, is contract review automation. So sometimes you don't have time, or professionals don't have time to review contracts manually. So they rely on machines to do this for them, or at least part of it. And this also is done and performed by machine learning models. So here I will be giving some concrete examples of what we are doing, and I focus on NLP as a subfield of AI, artificial intelligence, and I'll be later talking about NLP in more details. So NLP is, as I said, a subfield of AI, where also we use different models like machine learning models and deep learning models, of course. So one of the projects I've been participating in the last period of time is the plant identification from digitized flora. So this is a project that's been conducted in coordination or collaboration with Institut de Recherche pour le Développement in France and Sorbonne Université. So basically, what is it about? It's the floras are kind of textual documents, and these are examples. These are examples of flora. We have in this project we had 27 books, and each book is like 100 to 300 pages each. And we needed to extract information from these books, from these resources, which contain typically descriptions and classifications of plant species. So of course you can imagine that if a human being had to go through each one of these books to look for information retrieval, it would be really, really hard to extract a desired information in an optimal amount of time. So our objective was to extract automatically information from these books in order to help extracting information easily. So typically, this is the content of this kind of books. Inside, we will find this kind of information or this kind of context. And of course, what we are interested in, we want to extract the name of species, We want to extract other information about the plants themselves, about their organs, about their the type of these organs, and how they qualify in the text. So we want a model that recognizes automatically the name of species in the text, that recognizes automatically the name of organs, and also the characteristics of these organs and plants, and which would extract all these information for us. So our problematic was mainly an information retrieval issue. Information retrieval and management is quite complex if we keep this data in this format, because, for example, if we want to have an answer to the following queries, it would be really hard to answer them. For example, what are all the species of genus X? What are the names of species with white flowers, for example, in New Caledonia? To answer this question, we would have to go through all the books, read every page, and then extract the information. So this is not a really good way to do it. So our objective is to kind of automate this process and this information extraction process, to produce a kind of a structured representation that would facilitate or make it easier to answer this kind of questions. And this is why we thought about training what we call NEAR models, named entity recognition models. And these are basically machine learning models which are trained on a specific training set that is presented in a tailored format. So we train our models on a training set, of course, and the objective of these models is they take as input a text, and they output the a kind of labels for each word or for each sequence in a text, and they assign if it's a species, it would assign the label species, if it's an organ, descriptor, etc. So basically, this is the output of the tool that we've obtained. It was deployed using Streamlit. So Streamlit is one of the interesting platforms that make it very easy for you to create data applications. So here, for example, the model took as input this paragraph, and as an output, we had this these words recognized or classified as description, as organ, species, or one or the other characteristics. And here, for example, we've moved from the unstructured format, which is typically text, which is very difficult to query, to this format, which is more a dictionary. And when you have a dictionary, typically it's more easier to retrieve information and to answer queries. Another example, and this is a project we've worked on, I would say like 5 years ago or maybe more. So it consisted of analyzing YouTube data to get insights on perceptions towards women in the Arab region. And because it's specific to the Arab region, we were like focused on the text or the content that is written in Arabic. So in this project, it consisted of 5 main research axes. And of course, it started with relevant content retrieval, because we wanted to analyze data coming from YouTube. But first, we wanted to identify which data we will be analyzing. So we have developed some specific queries to retrieve the videos that we wanted to analyze. And in fact, what we wanted to analyze is not only the videos, but also the comments, and mainly the comments that are reported or that are associated to these videos. So we started with a kind of videos classification using the metadata, which means the title and the description. And of course, here again, this is a classification problem. So it's supervised learning. We've used a machine learning algorithm. We've compared different ones, and we've used the most performing one, which maximized the metrics. Second, we've used sentiment analysis applied to comments this time. So in sentiment analysis, it was not a machine learning approach. It was what we called a lexicon-based approach, where you rely on a certain lexicon to detect the opinion orientation of a given text. And then because we wanted to have a kind of disaggregation of these comments also by sex, I mean by gender, to know if males or females were more likely to express a certain position or a certain perception towards a certain topic related to women's well-being. So here we've developed a model, a machine learning model that automatically identifies the gender of a comments author from the text they share. So imagine it's a model that takes as input a comment and that outputs the gender of the author, male, female, or unknown. And we finished with a geographic disaggregation of authors, and because also we wanted to know maybe there is a specificity about Arabic. You have classical Arabic that everyone talks it, but it's more like academic Arabic. It's not the Arabic that we speak in everyday in our daily life. In each country, we have a specific dialect. And by recognizing the dialect, it's possible to recognize the country of the speaker. So here we have developed an approach to detect the geographic origin of the commenter or the author of the comment based on the dialect the comment speaks. So we have developed an approach. It was again a machine learning model which identified the dialect given a comment. So you have a comment as input, and in output you have a label. Which dialect is this? Is it Morocco? Is it Algeria? Is it Syria, etc.? So these are just metrics to give you an idea about the collected data. Just I want you to focus on this. For example, what we have analyzed in total was more than 44,000 comments. And of course, we wouldn't have been able to do it manually. And this is all the interests of machine learning. It helps you automate or introduce automation in many tasks, and it helps you also accomplish tasks that would have been difficult for humans, or that would have required a lot more substantial human resources investments. So here is just about how we did to build these models. I think if you want more details about it, we can discuss it during the Q&A session. Sorry. Okay, so this is, for example, the dataset that we've used to train the dialect identification model. So you can see here that we have like two levels, a level which consists of, or which is interested in the region of the dialects, and then you have the countries. And here are the sentences, which is kind of the overall size of the data set, or the training set that was used for training these models. The other project that we've worked on is similar to this one. It's more recent. It's this is something that we delivered like last year, and it was about mining the web for insights on violence, online violence against women. And we were interested in a certain country, which is Libya, and we were interested specifically in women which are which have some form of political participation. So of course we've started with data collection. So we've collected a certain number of posts and then a certain number of comments coming from different pages, Facebook pages that we have identified previously with the team of the project. And to this comments, we've applied two, I would say, types of analysis. So the first one was only metadata analysis. I mean, by metadata, it's not the content of the comments or the content of the posts that we are analyzing. It's more the metrics around it. And I will be sharing a few figures about this in a while. And we've also applied NLP. NLP is something similar to what I've shared in the last project. We've developed machine learning models which recognize offensiveness in this case and misogyny from the comments and the posts. When I say metadata analysis, what we know, or maybe what I want to share with you, is with the when you collect a post, when you collect a comment, you also collect the metadata. You collect the ID, the name, the number of shares, likes, loves, etc. So these are things that could also provide some insight about the comment itself or the post itself before diving in the content or the actual text that is represented by the comment or the post. And here I'm sharing with you two tables like which feature the different metadata that are being collected in the case of the posts and in the case of the comments. This is an example of our data. You have a comment, the time it's being collected, the number of reactions, number of likes, and etc. So this is an example for metadata analysis. So here we've only plotted the for the sad reaction, for example, and here you have how many sad reaction we have, and here you have how many comments we have. And the size of the circles represent the number of shares. The color is the category, because we have categorized our Facebook pages into a certain number of categories. Is it like popular pages? Is it a page that is associated with a female minister, etc.? And here we can see, for example, that many of the comments that have said reaction have been shared, for example, like have a substantial number of shares. And there are other observations that we can also see from this graph, but this is not the objective. I just wanted to show you how the metadata could also inform about the content itself. This is also a certain format of it's a visual it's a visual that is generally used in NLP and text mining when you want to have the most frequent words in a data set or in certain content. You can plot it this way, and the most important or the most frequent words would appear clearly within the word cloud. And for the NLP part, as I explained, it's supervised learning again, so it's a classification. We have developed two models. The first one takes as input a comment or a post, and it detects its offensiveness. So it associates a label, offensive or not offensive. And then we have another model which is specific to misogyny. We want to know if a comment like features misogyny or not. And of course, as you know, in both models, we have used training sets which provide examples of offensive sentences, not offensive sentences, misogyny, and non-misogyny sentences, and then we trained our models. And once we get the model trained, we applied it to extract this information from the collected comments and posts. And here is an example. Again, in the deployment, we have used Streamlit. So we have a text that's written in Arabic, and we have the output of our models when it classifies it as offensive, like with a certain broadly offensive, and it features misogyny, like with a score. This is a kind of a confidence score that is being also shown to help the user also have a kind of a critical thinking about the results provided by the models. So these were kind of some of the results that we've obtained after applying this model on our data. The other project I wanted to share with you is called Nauras, and it's about using artificial intelligence in the context of law. So as I showed earlier, we have in the plant identification project, we have applied NLP machine learning to Flora, numerized books which contain description of plants. Here we will apply our methods to legal documents to extract information. So the set of methodologies and techniques is quite the same, but the data is different, the objective is different, and the information we want to extract is different. So here, this was our starting point. Audeline Bion has prepared a PhD thesis on it was purely law, and her job was to come up with indicators about certain, I mean, selected countries, indicators about the efficiency of their law regarding environment and environment protection. So Audeline, to inform these indicators, she had to go through legal documents in each of these countries. So she had to collect them manually, she had to read them manually, and then to inform the metrics to at the end of the analysis get to this visual. So it's a work that took her around 3 years or more. So our idea was would it be able, our question was, would it be able to produce these kind of indicators without having a human being spending this much time on reading the legal documents, and introduce a kind of automation in the process? And this is how we started the PhD thesis of Youssef Al-Mu'tamid that we are currently supervising with Marie Bona. So the objective basically is to go from an instructed format or an instructed representation, which is basically text, to something more structured. Here we have just a simple database, which would facilitate or help retrieve or help answer queries compared to this format. So we have been working on this like since 2 years now. There are different stages or different modules in this project. We had to start with segmentation and OCR, which is not always an easy task, because even with the performing tools that you guys maybe are using every day to apply OCR to your documents, this is still an active research field, because there are things that we cannot accurately segment or to which we cannot efficiently apply OCRs. For example, here, just to make the difference between OCR and segmentation. OCR is when you have an image and you want to extract the text. Why I say it's not an easy task, especially in legal text, because many of the legal texts are scanned in quite poor quality. So if you apply an OCR directly to these two images, so there is a lot of characters and words that won't be like extracted correctly. So this is the first I would say limitation, or the first challenge. So apply OCR to poor quality images like the ones I show here. And the other one is segmentation. Segmentation is when you succeed in extracting logical parts from your text. For example, in legal text, it's organized in articles, chapters, sections, etc. And we are interested only in articles, for example. So we want a model that segments the image to extract only articles or lists or etc. to have a kind of hierarchy in our analysis. And this is when we have used segmentation. And of course, OCR and segmentation are both machine learning based approaches. In the automatic extraction of legal information part, when we have finished with segmentation, OCR, etc., now we have the raw text and we can apply different techniques. For example, we can start with classification. Classification, we take an article and we classify it depending on its content. In our work, we have defined 4 or 5 classes. Whether an article, for example, features a definition, does it feature, for example, a ban or a sanction or whatever. So we had this done using a model based on Camembert. Camembert is maybe you've heard about BERT, which is a language model. Camembert is, or Camembert is the French version of BERT. So this is what we have used as the base for our training, and of course we had to create a training set and to which means have texts and annotate them. The other parts beside classification is information extraction, and here basically you apply sequence labeling or you apply named entity recognition to extract, for example, from this article we would want to extract the amounts of the sanction or the duration of the of anything, I mean, depending on the articles we are analyzing. And of course, the final objective of all this process, which starts with OCR segmentation, then classification, legal information, is to store this the information that we extract in a certain database in order to inform dashboards like these, which would include the indicators I showed you earlier, which were extracted and realized by Odlin manually. So we want it to be an automated process. Ecolex, which is the website or the database from which we get the raw texts, the legal texts. Then we have what we call an ETL, which is basically extracting information, transforming it, and loading it in a database. And our models will be incorporated here at this stage. Once we have the database, we can like inform our dashboards. And there was also, before all of these things, there was an initiative in the where we tried to apply NLP to art, and this was in collaboration with Université du Luxembourg. So one of the projects was Intelligent AI Critique. And the objective was to have as input an image and to produce as output a kind of a critique to this work. And here what was used is more a kind of generative AI, not a discriminative model. Here also is another project called DALL-E Mates, and it's about image generation from textual input. So this is a kind of multimodal model. It's a multimodal model is a model where you use typically different modalities, not only text, but also image, videos, etc. And the ChatGPT 4o that has been released a few days ago is a typical example of multimodal models, because it accepts not only text, but different types of input, and it was also trained on different types of inputs. Okay. So this was an overview on, I mean, I shared with you like some key projects that we have been working on during the last years. Now moving in, I mean, now we'll be speaking more about NLP and the LLMs. As I explained, natural language processing is a subfield of artificial intelligence, and typically it includes natural language understanding and natural language generation, because, for example, when you speak to a chatbot or a conversational agent, the agent needs to understand what you say before it generates an answer. So understanding means understanding your intent, the domain in which you are asking your question or discussing, etc. And once it understands, then it generates the natural language. And of course, as you said, as you saw and as you know, natural language processing has different applications: dialogue agents, sentiment analysis, as I showed, and also translation. DeepL, for example, is something that is a tool that you have used before. So DeepL is typically an example of is an application of NLP. Paraphrasing, text writing, etc. And just a note to make sure that everyone understands the difference between discriminative and generative models, not only related to NLP, but generally related to machine learning. Generative models is when you have a model which generates a new data. For example, you provide the beginning of a sentence, then it produces a paragraph for you. Or you provide a text or a prompt, then it produces an image for you or a music for you. So this is a generative model which generates something new based on some kind of input. Discriminative models are different because they kind of focus on predicting the labels of the data. What I've been showing, like for the offensiveness model, for the dialect identification model, etc. So all these are discriminative models because we provide as input a comment or a text or whatever, and as an output we have a kind of label. Is it offensive or not? Is it Moroccan Arabic or is it something else? So this is a discriminative model. And of course, NLP and classical pipeline resembles to machine learning classical pipeline. You have data acquisition. In our case is mostly text. You have pre-processing and the data representation, and then you can model your modeling is where you actually train your models. Then you can evaluate, deploy using, for example, Streamlit, as I showed you. Especially if you are a beginner, it's easy to do. And then you can update your model. And of course, we can also, we will have generally to regularly or periodically update our model depending on how it's being used. Language models vary in complexity, and what we see today is mostly something that we call data-driven language models. And data-driven language models are simply put, giant neural networks that are trained on massive sets of data, books, articles, code, the whole internet. And by analyzing these vast amounts of text data, the language model learns the relationships between words, sentences, and concepts. And we can think of these models as superpowered language learners who have absorbed vast amounts of information and can use it in creative ways. Now with the LLMs, especially ChatGPT is not the only LLM out there, but it's one of the most known ones. And with this rise in using LLM-based tools, there is a call for some skills that would help maximize the benefits of these LLMs. And I think this is something I've already said. Large language models are advanced deep learning systems, which are designed to understand and process human language. They are trained on massive data sets. They have been trained using complex technical architectures based on artificial neural networks, and they benefit from very important processing resources. And LLMs is not something that's been created only with ChatGPT. We've started talking about, this revolution came with what we call transformer architectures, which were introduced in 2017 with the paper Attention is All You Need. So this transformer architectures kind of it was a kind of a revolution for NLP applications generally. So after that, Google have proposed BERT, and then OpenAI have proposed GPT, which was at that time the language model proposed by GPT. And from then we had different LLMs being created. And in 2024, we had new innovations. We had a new Llama model. We have the GPT 4.0 now. Google Bard is not called Bard anymore. It's called Gemini. So it's progressing very, very fast, because one of the drivers of this, I would say, movement is the availability of processing powers. There are downsides for LLMs, but also for machine learning in general. And here I will focus on LLMs. For example, they could suffer from hallucination. And I invite you to check this article that I mentioned here in the, you can find the reference here. So this is a study that was performed on ChatGPT 3, and to see if it's, how it reacts to a certain number of prompts. So here, for example, the question that was asked to ChatGPT was, where do people smoke more on average than in Russia? Then you have a response provided by ChatGPT, and it resembles, at first sight, you could see that it's quite reliable. It provides statistics. It provides even references, World Health Organization. But actually, when the authors checked, it's kind of false, because the generated answer includes wrong statistics. So this kind of hallucination, we call it extrinsic hallucination. We have also intrinsic hallucination, when sometimes there is a kind of contradiction between what ChatGPT says. Here, for example, when the authors asked ChatGPT to describe how the Mexican flag looks like, it answers that it consists of 3 vertical bands in green, white, and red. It mentioned that it's vertical. However, when the user asked ChatGPT 3 to generate a code snippet to represent that flag in SVG format, then it produced a horizontal bands, not vertical. So this is called intrinsic hallucination. So this is just to say that LLMs have downsides, and machine learning in general have downsides. For example, bias is something that that we should be aware of when we manipulate or work on machine learning models, because machine learning models can be biased if trained on biased data. And of course, bias can lead to unfair outcomes for individuals and groups of people in different areas, such as employment, healthcare, and criminal justice. Here, for example, it's quite old now, but it's an interesting figure, I think. Here, the authors of this work have compared the accuracy of face recognition technologies depending on the gender and the shades of the and the ethnicity also of the people being included in the study. And we see, for example, that for all, we have here 5 face recognition technologies, and they all fail. It's the red one. They all fail in correctly recognizing faces of females with dark skin. And this is a bias that could lead to negative outcomes for females with dark skin, especially, for example, that we are more and more using AI in hiring and in recruitment and in automatic screening of resumes and automatic screening of videos that are being shared by the candidates. So as I said, the downsides for LLM specification is hallucination and bias, not only for LLMs, but also for machine learning. And there are some risk mitigation measures that we can take, especially AI fine-tuning and prompt engineering. AI fine-tuning, what do we mean by that is that we can take a pre-trained AI model, like I showed in the previous slides. We have taken Camembert, which is a pre-trained AI model, and we have adjusted its parameters by fine-tuning it on our specific data set, which was, of course, much more smaller and which was also specific to our particular task. So one of the measures to, to deal with the downsides of that I have discussed earlier is to use fine-tuning. And this is a simple way to explain it. You can think of it, fine-tuning as a specializing a doctor trained in general medicine to become a cardiologist, for example. And there is also, and this is specific to LLMs, there is also prompt engineering, because the way you are asking your question can heavily influence the answer of the LLM you are dealing with. And prompt engineering is the art and science of crafting optimized messages to get the desired output from a given LLM. And basically, it's a process of structuring and refining a text. Refining a text, in our case, it's a prompt, to optimize the performance and response of large language models. And generally, prompt engineering should lead to optimized responses when dealing with LLMs. And there are 3 most known types of prompting. We have what we call N-shot prompting, zero-shot and few-shot prompting. And here I will be focusing on zero-shot and few-shot prompting. So zero-shot is a technique for instructing large language models to perform tasks without providing them with any training examples. For example, I give a comment that I have, for one of the comments that I have collected in the previous projects I shared with you. I give it to ChatGPT and I ask ChatGPT, is this a comment that features offensiveness or not? So this is zero-shot prompting. Few-shot prompting, I would give examples to an LLM like ChatGPT, and then ask my question. And here I share with you an example of few-shot prompting. Before we ask ChatGPT to classify this comment or this text, horrible customer service, I give it examples, few examples of what makes a text positive and what makes it negative. And then I ask the question to ChatGPT, and here I am more likely to get a correct answer, especially if I'm working on a very specialized area. So I'll end my presentation with this. Here I'm just sharing with you a quite interesting paper where it provides categories of prompt patterns, and it shows you how you can deal with different, depending on your objective, how you can craft your prompts to efficiently use LLMs and to get to the most optimized possible response. So that's it. I hope it was informative to you, and if you have any questions, I'll be happy to answer.
Thank you, Jihad, for the nice presentation, and thank you for being focusing in the main point of this today webinar. Thank you. Yeah, we have some question in the chat. I will be reading the first one. So, what were the conclusion of the gender video research? It was one question when you display the output of the first model about gender.
Okay, do you want me to take all the questions or to answer the questions one by one?
No, I'm just reading the question. You can read them by yourself if you like.
Because I need to, okay, I don't see
Yes.
the, I need to stop the,
Do you
okay.
see the question? I guess Thomas is sharing them.
Okay, yes. What were the conclusions of the gender video research? What I found interesting, I mean, many conclusions, but what I found interesting was that there was a part when we talked about education and economic violence and harassment also. Yes, maybe I will share with you the one on harassment. Many women think that harassment is the responsibility of women. And it was kind of surprising because I would expect that I wouldn't expect that coming from females as I would say as a statement. So this was one of the conclusions that like have marked me. The other one is economic violence. Many women complained about the additional burden of the economic participation. Yes, it's a way to participate and to have some independence, but also because we have other roles in the household, it's being seen as a kind of it's a workload that's being added on their shoulders, and it was interesting to see how they interact and how they see this economic empowerment, not always as something that is purely positive or purely at their advantage. Can your offensiveness model be trained for other languages? Of course. It all depends on the data you provide. For example, you can use a pre-trained model, which was pre-trained on English, for example, and then you can fine-tune it on other languages, or you can do it from scratch. Take your model and then prepare your data set. Or find a data set that is available on internet. For example, offensiveness, there are many data sets that are available in different languages. And you can take this data set and train your model depending on, to get the desired output. Okay, in the YouTube project, the gender is recognized based on stereotypes taught to the machine, if I get the point. But the slide was overlooked. So that would mean that my analysis by gender and resonance, maybe regarding the metadata analysis, what is missing is no reaction. What I do personally when I disapprove a content to avoid to give it. Yes, this is a very good point. This is why I mentioned bias at the end of the day. We know at the end of the presentation, we know that some models have limitations. They could be biased because, for example, to build our training set, we were based on the names that were provided by users, and we used a database which linked a name to a gender. So one limitation would be, for example, I am a female, and I would use a male pseudonym or a male name, and my comments will be classified or will be associated with a male with a male label. And this is one of the limitations. Regarding the other comments, yes, actually in our study, the metadata analysis was much more, I would say, elaborated. But here I thought of just giving you a glance, I mean, just giving you an overview of our main, the main idea behind the analysis. How was offensiveness and misogyny defined? This is an interesting question because we had a debate on this. If offensiveness is anything that is kind of broader than misogyny, offensiveness would include profanity, vulgar statements, extremism, racism, etc. So it's more general. Misogyny, we had several meetings with the responsible of this study, and we asked them like to define in their point of view what misogyny is. And we have based our work on definitions by that are included in CEDAW and that are included in many documents provided by the UN. And to make sure that we are correctly classifying or annotating our data, we had volunteers annotating the comments, misogyny or not, and then we had experts from UN Women to validate this annotation to make sure that we are addressing misogyny the way it should be addressed. What criteria? It was not complete. What criteria did the AI model use to score these two things? How are they different? Isn't a misogyny comment always offensiveness? Yes, but the other way is not. Of course, once it's offensive, we go and see what kind of offensiveness is this. So a misogynist comment is offensive, but an offensive comment is not necessarily misogynist. What is the difference from transformer architecture with recurrent neural network that we saw during the previous webinar? It's a difference in it's a difference in the architecture. With the transformers, we have what we call the attention mechanism, and it provides, or it focuses, it gives attention to certain parts that improve generally the accuracy and the performance of the model. Okay, thank you for this presentation. How is managed the possible error in the results? Referring to statistical confidence on results provided, like misogyny score. Yes. Exactly. So generally, when we deliver our work, we provide an overview of the performance of our model. As you know, no model is 100% performance. You could say like it's 96%. So it means that it recognizes correctly 96 comments from 100. So we provide this information so the reader or the user of our model is aware of its limitations. And we have also, generally, we can also share a confidence. It's similar to the score I've showed in the presentation. The model would say, okay, I think this is misogyny. I am 50% sure about it. So it's kind of ambiguous to the model. But if it says it's misogyny, and I am sure about 99% about it, then I am more likely to take this output more seriously. Okay, perhaps not directly linked to the talk, but I was wondering if you have any recommendation for teaching an introductory course on AI, specifically to use for students of the humanities who have no background knowledge on this topic. Recommendation. I don't have. I don't. I don't. I don't have it in mind, but maybe I can look this up and maybe share it with you in Reddit. Maybe I'll find out something there, and I'll be able to share it with you.
Yeah, one other question. I just saw it in the chat. What are good metrics for evaluating large language model?
Evaluate. It depends on the task. It all depends on your task. For example, you are using LLM for classification, supervised learning. You could use the metrics, the accuracy, the precision, the F1 score, etc. If you are using it, for example, for summary extraction, you can use Rauch metric. You can use, for example, if you are using it for translation, you can use the word error rate. You can use other metrics. So in fact, if you are training an LLM itself, you can use perplexity, for example, because you want to minimize perplexity when you are training an LLM. So it really depends on the task you are using your LLM for. And as I said, there are different tasks, and for each task, you need to use a dedicated set of metrics.
Yeah. Thank you. Any other questions? So I don't see any question in the chat. And yeah, I want just to go back to the question of the difference between recurrent neural network and the transformer, because this question has been asked many times. And last time I remember I have given the difference in terms of architecture, which you just explained. It's about, so what makes the difference? It's the mechanism of the self-attention to weigh the importance of the word in a sentence. And this is what makes the difference. I just want to elaborate more so that our participants understand more the difference between these two architecture. So recurrent neural network, or RNN, it processes the data sequentially. That means word by word. It uses a hidden state to update sequentially the word as it arrives in the input layer of the architecture. Unlike the transformer, it doesn't process the data by sequence, but in parallel, which means that he used a mechanism which Dr. She had said, to put attention to weight the importance of the word, which means that it processes the word of the sentence in parallel, all of them at once, at the same time. And this is what makes the performance of transformer better than the performance of the RNN. So the RNN, it is a slow in terms of training, of processing, due to the sequential process, but the transformer comes to mitigate the risk of the RNN by using this attention mechanism. So which allow to look to the entire sentence, to the word of the sentence. So I hope that this elaboration was enough to explain the difference between these two architecture. I want just to check if there is any question in the chat. Yes. So yeah, I think we come at the end of this presentation, since we don't have any question in the chat. I want just to remind you about the next webinar, which will be about a deep dive into exploring generative AI from neural network to practical application by Dr. Salima next week at the same date, at the same time. I hope that you enjoyed today's webinar. Thank you, Dr. Shihad, for taking the time to give us this presentation and to answer the question. Thank you to share it us with us your work and your output, the research as well. So thank you.